Okay, this is part B. It's about the understanding of key scientific processes. Okay, I don't want to throw equations at you. I don't want to go into the deep scientific details of how processes work. I just want you to that you understand the key features. Okay, so let us start with thermal radiation. What is thermal radiation? Thermal radiation is a most important part for you to understand how the climate works. The starting point is the radiation that comes from the sun, solar radiation. Okay, it's a form of energy transmission by electromagnetic waves, EM waves. And now comes already the key feature. All surfaces emit heat radiation. Okay? And the electromagnetic waves can be characterized by a specific peak wavelength, by one particular wavelength. And it's the surface temperature that controls this wavelength. It's known as Wien's displacement law. So surfaces of different temperatures can be distinguished. You can distinguish the temperatures, and I show you some images here. There's a house above my head, and there is a wolf here on the left. Okay, with infrared thermographic cameras, you can distinguish the surface temperature. Okay. So now the sun emits shortwave radiation in the visible light range, and the Earth emits long-wave radiation. And the understanding that both sun and Earth emit radiation is fundamental in the understanding of the greenhouse effect. Okay, it's very, very important. Okay, and this is what we call thermal radiation. Okay. And radiation comes in an energy flux or in a heat flux. Okay? And what a flux is, we talk about that in part C. All right. So the second thing I want to talk about is, what do we mean by transmission, absorption, and reflection of electromagnetic radiation? There's the three words, and you should be able to understand the meaning. So if I say in the future absorption, you should immediately know what I mean by it. If I say reflection, you should have an idea of what that means. So first of all, you think about, you have a medium. And what is a medium? You can have a gas layer, or you can have a surface of some substance, like the surface of the ocean, or the soil surface. Transmission means the passage of electromagnetic radiation through a medium. Okay, like if you have a gas layer, then a fraction of the radiation coming in will be transmitted through this gas layer. And maybe all of it, or maybe part of that. Okay? The part that is not transmitted is either absorbed or reflected. Okay? So first of all, what do we mean by reflection? Reflection is the amount of energy flux returned by a surface without absorption or transmission. So there's a little sketch up here, and reflection is the one that bounces back. Okay? And that, if it's not absorbed, this reflected energy, if it's not absorbed, is just lost. It just goes. If we're talking about the reflection of solar radiation, if nothing else happens, it's just reflected back into space. Absorption, however, is now the amount of energy. Okay, it's actually an energy flux. You'll learn later what a flux is. That is actually converted into internal energy through changing of the temperature of the medium. Okay, so the absorption, for example, of a heat flux can trigger warming of surface layers of the ocean, warming of the top layers of soil. Okay, or absorption also by gases can heat up air, in different. We already talked about the ozone layer. You could see that heating effect, in the temperature structure. So it's really important to understand these three words. Okay, so now a little bit more. It's about phase changes of water. And I just want to really introduce you to these words, because we will talk quite a bit about these words. Evaporation. Okay. Transition from liquid water to water vapor. Okay. And evaporation. Okay, it's the water vapor is a gas much lighter than liquid water. So evaporation is associated with an energy flux or a heat flux. And the process of evaporation takes up heat and leads to a cooling effect. And evaporation in terms of the heat fluxes is extremely important over the oceans, and it sort of balances half the energy flux that comes in from the solar radiation. Half the warming effect due to solar radiation is balanced by this cooling effect over the ocean. Okay. Condensation is the transition from water vapor to liquid water or ice in the atmosphere. It induces cloud formation and precipitation or snowfall. And this process releases heat. Okay, it's an internal heat source in the atmosphere. So if you have that condensation, you get an extra amount of heat that further influences the dynamics. Okay. So the other two processes I want to talk about is freezing and melting. Okay. Freezing is the transition from liquid water to solid ice. Okay. For fresh water, the freezing process takes place below temperatures of 0 degrees Celsius. This is how the zero has been defined. For seawater, the effect of salinity lowers the freezing point temperature to around -2 degrees Celsius. Okay? Ice has a lower density than liquid water and therefore floats. That's an extremely important feature of the climate system. Melting is the transition from solid ice to liquid water. Meltwater has a lower density than seawater and therefore remains at the sea surface. Okay? So, all right, I just want to throw these words at you because in future lectures you need to know what I mean by. If I say condensation, yes, you understand it. If I say evaporation, yay, you understand it. If I say freezing, hooray, you know what I mean. Melting, yes, everything is clear. If you don't understand these very basic words, then you will be terribly lost. Okay, so do your best to understand this stuff. And this is the end of part B.